Okay students, so in this part I am going to discuss you about PN junction diode. This is the first semiconductor device which I am going to discuss amongst you. Let us see what happens when two different types of semiconductor, that is P-type and N-type, are combined. So let's start. Okay friends, so now let's see the next topic, PN junction diode. So basically this is the we are trying to do here is, so we will be joining up the P-type and N-type semiconductor, and we are trying to make a device, semiconductor device, that is called as the PN junction device. Okay, so let's see how it works. So basically a PN junction diode, if we talk about a PN junction diode, so we have learned what are the P-type semiconductor and the N-type semiconductors. So when we join the N-type as well as the P-type, okay, then the device which form or is called as the PN junction diode, right? See, the P and N, because we are joining up the P-type and N-type semiconductors together, right? Now why junction? So whenever we will be joining up P and N, right? So let's suppose this is, if we see in the figure, so this is a P-type semiconductor and this is the N-type semiconductor. So when we join them, okay, side by side, so there is a junction, okay, which exists on the interface of this P and N, right? So therefore we use the term called junction, and the last one is the diode. Right, so this device is called, this device, this PN junction, this device is called as the diode, right? So this is a semiconductor device, or we can say this is the first semiconductor device which we are studying, right? So now see what happens when we join the P-type and N-type. We know that the P-type has majority of holes are there in the P-type, and in N-type semiconductor, the majority charge carriers are electrons, right? So whenever we join this P-type and N-type, now since P-type semiconductor has more number of positive charge carriers, right, that is holes, and N-type semiconductors has the more number of electrons as a charge carriers. So whenever we join this, so there is due to this positive negative attraction, right, so the electrons from the N-type, okay, go cross this junction, okay, and comes in the P-type, as well as the holes, that is the positive charge carriers in the P-type, okay, moves from the P-type to the N-type. This is all because of the attraction between them, right? So we can say that the holes from P side diffuses to the N side, while the free electrons from N side diffuses to the P sides. Okay, now let's see what happens. So whenever this N-type electrons diffuses from the N side to P side, okay, and the holes from the P side to N-type, so there will be a recombination of this electron and hole pair, right? And this recombination will take place, okay, nearby the junction, okay. So there will be a layer form or the region form, that is called as the depletion region. So here a region will be formed that will be called as the depletion region, and that region will contains all the this bonded electron hole pair, and they will be immobile, right, because now they have been bonded, so now they will not be available for the movement. So they will be called as the immobile electron hole pairs, right, in the junction, that is the depletion region. So that region in which the immobile atoms will be present there, that will be called, that region is called as the depletion region. So this movement, why this movement occurs? So this movement occurs because of the charge density gradient. So there is a gradient, charge density gradient. Why? Because the N-type has more number of electrons and there are less number of electrons in the P-type. So there is a charge gradient. And if we talk about the holes, so there are more number of holes in the P-type, but they are less in the N-type. So there is again a concentration, right, charge density gradient is present there. So this leaves the negative acceptor ions on the P side and positive donor ions on the N side uncovered in the vicinity of the junction, right? So thus there is a negative charge on p side and positive charge on the n side, right? So since the electrons has moved from n side to p side, okay, and the holes has moved from p types to n type, so there is a recombination takes place, and due to this recombination the negative charge carriers will be left on the p side and the positive charge carriers will be left on the n side. So now this sets up a potential difference across the junction which I was talking about, that depletion region. So this sets up the potential difference across the junction, and hence an internal electric field from n side to p side, okay, exists there. So due to this recombination, okay, there is a depletion region will be formed, and that will contain immobile electron hole pairs. Okay, so there will be so if we move, if you see in the previous slide, so we can see that, so here the negative electrons has taken place, and this the positive ions has taken place. So this will be immobile because of the recombination of the electron hole pair, right? So therefore we can see the electric field will exist here, okay, in this junction. Now, so equilibrium is established when field becomes larger enough to stop further diffusion. See, we know that whenever we are joining the n type and p type, so the number of electrons from n type starts going to the p side, and the number of number of holes from the p side starts going to the n side. Now they will be continue going till when the large equilibrium is established, right? So equilibrium is established when the field becomes large. So we know that this field is being established in between the junction. So whenever this field becomes larger, to stop that further diffusion of the majority charge carriers, okay, so then the equilibrium will exist, okay, and the region which becomes depleted free of the mobile charge carrier is called as the depletion region. So I was saying you that the region which becomes depleted, so it has depleted of a mobile charge carriers, is called as the depletion region. The potential barrier across the depletion region is called as the potential barrier. So the potential that will exist in that depletion region, that will be called as a potential barrier, and that will actually oppose the flow of the majority charge carriers from one side to the another. So that will basically act as a resistive force in between the two type of semiconductor. Width of depletion region depends upon the doping level. Okay, so higher the doping level, thinner will be the depletion region. Okay, so there is always so whenever if we are increasing the doping level, then the depletion region will be decreased, and there is a relation which says that Nd into Wn will be equal to Na into Wp. So that is the product of concentration, okay, into the width in the n type is equal to the acceptor concentration in p type into the width of depletion region in the p type. So this will be, so from here we can see that the width is inversely proportional to the concentration. So higher the doping concentration, the thinner will be the depletion region, right? So now let us understand what is this forward bias of an PN junction, right? So whenever we are having a PN junction, first of all let us see a PN junction diode is represented by this symbol. Okay, so this is a symbol basically to represent, and here if you see this base of a triangular is represented by a P type, and this line passing through this vertex and parallel to this base, we can say, so this is called as an N type, right? So this terminal is called as an N type, and this terminal is called as an P type. So this is a P type. So this is a symbolic representation of an PN junction diode. So this is a positive and this is a negative one. Now biasing. So there are two types of biasing, forward biasing and the reverse biasing, right? So if we apply a positive potential to p type of this PN junction diode and negative voltage to the n type of this PN junction diode, then this correction is called as the, or in this state the PN junction is called as bias in the forward bias. So this is called as a forward bias, right? So when external voltage is applied to the PN junction, making the P side positive with respect to the N side of a diode. See, the P side should be positive with respect to N side. It is not compulsory that we should give positive voltage to P and negative voltage to N. There may be both may be positive, both may be negative, one of them may be grounded, right? Or there may be any other possibility. But the thing is, for a forward bias case, the voltage at P terminal should be greater or should be more positive compared to the N side of a diode, right? So in this case, what will happen is see, we have connected a positive terminal here and the negative terminal here. So that means the holes of an P side will be repelled, okay, and the electrons in the N side will be attracted here. So we can say that there is basically a flow of electron in the circuit. So there will be a flow of electron in this device, and therefore the current will be formed. The current will flow in this loop, right? So we can say that a large current will exist when we apply a forward bias to an PN junction. So barrier potential. So when we apply a forward bias, the barrier potential difference is decreased, okay, and this is due to the external applied voltage, because we are applying external voltage, and this external voltage is helping the charge carriers in the diffusion process. That means we can say that the potential difference, that barrier, is the effect of that has decreased, okay. The depletion band narrows, which asks majority charge carriers to flow across the junction. This is what we have discussed. Whenever we apply an external force, right? So basically it so if when you apply positive voltage to P type, so it repels the positive charge carriers, that is holes, and the negative terminal on the N side repels the electrons, right? So there is basically, so in this we can say that they are basically providing extra energy for the majority charge carriers to diffuse through the junction, and hence we can have a current in the circuit, right? So therefore we can say that the forward bias diode has a very low resistance, because by providing the external voltage, actually we are helping the charge carriers to diffuse the junction, right? So therefore the resistance becomes very low. Now if we talk about the reverse bias PN junction, okay, so what is reverse bias? So we see that in forward bias we are applying a positive voltage to the P side and negative voltage to the N side. So in reverse bias, this will be a reverse condition. That means when we apply an external voltage, okay, to an PN junction, making the P side negative. See, what we are doing is, now we are making P side negative with respect to the N side of the diode, okay, and this is said to be as the reverse biased condition. So whenever we apply a negative voltage, see, negative voltage to the, we can say that the P side is negative with respect to the N side. So for this case, we see that this is called as basically the reverse bias case. Now let us see what happens. See, we know that we are this is a P type and this is an N type, and we are applying a negative voltage here, let's suppose, and positive voltage on the N side. So this is a positive voltage and negative voltage, and we know that in P type we are having majority as holes, and in N type the majority are the electrons. Now if you see here, the positive terminal will attract these electrons and this negative terminal will attract these holes. So we can say that this majority, instead of this flowing the majority or the crossing the majority charge carriers through the junction, what it is happening here, they are pulled back, okay. So this positive terminal will attract these electrons, and this holes will be attracted by the negative terminal. So there will be not, so there will, we can say that ideally there is no electrons or holes crossing the junction, right? So there will not be a flow of current. So we can say that there will be a very small current, and that will be only due to the, now why this small current come here? This comes due to the presence of the minority charge carriers. We know that in N type there are majority are electrons, but there are some minority holes are present, right? And that will be repelled. And similarly in the P type we are having electrons as an minority charge carriers. So due to the presence of the minority charge carriers, the small current flows in the PN junction, but we can say it is very negligible in amount, right? Therefore so a very low, we can say it provides a very high resistance, okay, when we talk about the reverse bias. So barrier potential difference increases, the depletion band widens, preventing the movement of majority charge carriers across the junction, right? So due to this reverse bias, so this depletion region, we can say it widens, right? And this prevents the movement of majority charge carriers across the junction. So they will not be, we can say that there will be not, there will be the current not be due to the majority charge carriers, right? And the reverse bias diode, we can say that it has a high resistance, right? Because it will it will pull back the majority charge carriers, and that will not be contributed for the conduction, right? So now let's see the examples, okay, on this topic, and let's try to answer them. So when a reverse bias is applied to a diode, it will. So what happens when reverse bias is applied to an diode, right? So it will raise the potential barrier, lower the potential barrier, okay, increases the majority carrier current greatly, none of this. See, whenever we increase, for the case of reverse bias, we know that majority carriers will not be generated, right? That will not be increased, okay. The only, see, we can see the effect will be either in the potential barrier, either it will be lowered or raised. So we know that in case of reverse bias, there is a little current, okay, flowing in the device. So we can say that the potential barrier, right, that is basically acts as a resistance, okay, that will increase, right? Therefore we are having a negligible current. So therefore the correct answer for this question will be option A. So due to the reverse bias, okay, the potential barrier will raise, it will increase, okay. Now let's see the another example. So open diode, ideal diode in forward bias and reverse bias can be represented as. So basically we are asked for the ideal diode case, the case of an ideal diode. So whenever we are having, see, we know that for a forward bias, the diode has basically a low resistance. This we know that a diode, if a diode is in the forward bias, it will have the low resistance. And if it is an ideal diode, then there will not be a current due to the minority charge carriers. So we can that there will be or we can say that that potential difference. So if we talk about the forward bias, though, so ideal diode in a forward bias case, so there will not be any formation of an potential barrier. So we can say that it will not offer any resistance to the majority charge carriers. So we can represent them with an short circuit, right? So we can represent a diode with a short circuit when it is biased in the forward case, okay. Now reverse bias, we know that in the reverse bias case, actually the resistance, the potential barrier rises, right? The width increases, or we can say the effect of potential barrier or the resistance increases for the majority charge carriers, okay. And if we talk about the ideal diode, so that will be an infinite, there will not be any minority charge carriers flowing through the junction. So we can say that so there will not be any current, see, right? So there will not be any current flowing through that device. So therefore we can represent it by an open circuit case, right? So this is for the reverse bias, fine. So therefore the answer will be short circuit and the open circuit. That is the option C. If you still have any doubt, you can post them for free on our website askIITians.com. Click on the option ask a question. After clicking over here, you can select the category of your doubt. After selecting your category, type your doubt over this box, and if you want to attach an image of your question, you can also do that by clicking over here. After this, click on a button ask a question. The expert at askIITians will answer your doubt within 24 to 48 hours. Okay students, so in this part we have seen PN junction diode. We have seen what happens when P-type and N-type semiconductors are combined. We have also seen what is the effect of external voltage applied across the PN junction diode. We have seen there are two types of biasing, forward biasing as well as the reverse biasing. In the next part, we are going to study conduction in metals. So stay tuned with us.